Rational exponents. In this section, you're going to be working with problems using the square root symbol. In this first slide, it says, recall that the radical symbol, which this is your radical symbol, is used to indicate roots. The index is the small number to the left of the radical symbol that tells which root to take. For example, we have what's called the cube root. When you have a 3 over that little line there, that's called the cube root, which represents, as I just mentioned, cube root. Since 2 to the third, 2 times 2 times 2 equals 8, the cube root of 8 is going to equal 2. So it's like taking the reverse of 2 to the third. You would take the cube root of 8 to get 2. Here's another way to help write the nth root, and that's by using fractional exponents. For example, if b is less than 1, suppose the square root of b equals b to the k power. So here we have square root of b squared equals b to the k. If we square both sides, we're going to eliminate the square root symbol on the left, and we would multiply the exponent k by 2. So on the left we get b to the first equals b to the 2 times k. So what we get here is 1 equals 2k. If we divide 2 to each side to isolate the variable k, k is going to equal 1/2. So for all b which is greater than 1, the square root of b equals b to the 1/2 power. And notice here how I show the steps. The steps are written down where you square both sides, take the power of a power property. You get m and n equal to one another, and then you divide both sides by 2. Here's some definitions working with 1 over b to the nth power. So a number raised to the power of 1 to the nth is equal to the nth root of that number. So here we have an example. 3 to the half equals the square root of 3. 5 to the 1/4 power is, notice how we have the 4 with the square root sign 5 underneath. That's the quarter root of 5. Here we have 2 to the 1/7, so we have the 7 over the little line here, and the number 2 under the square root sign. So notice, looking at the base of the exponent when it's in fraction form, that base value, that bottom denominator value, is the value you see representing with the roots, with the nth root, we call that. If b is greater than 1 and n is an integer where n is greater than or equal to 2, then b to the 1/n equals n square root b. b to the half equals the square root of b. b to the third equals cube root of b. b to the 1/4 is the quarter root of b, and so on. So when b equals 0, the square root of b is n, which equals 0. When b equals 1, square root of n, square root of b with n equals 1. Let's look at some examples here. We're going to simplify these expressions. Looking at a, we have 81 to the 1/4 power. So the first step we're going to do is we can write this with the radical symbol. So we have 81 to the 1/4 is the same as writing it as the 81 under the quarter root, we could call that, which equals 3. And in your calculator, if you take 81 raised with the exponent to the 1/4 and parenthesis and then press enter, you should get the value of 3 in your calculator when you simplify that out. Let's look at the next one. We have 121 to the 1/2 equals 256 to the 1/4. So the first thing we're going to do is write this with the radical symbols. So we have the square root of 121, the quarter root of 256. So when we simplify that out, square root of 121 is 11, quarter root of 256 is 4. 11 plus 4 is going to give me an answer of 15. Here we have a definition. It says a fractional exponent can have a number other than 1 as the expression of b to the 2/3 power. you can write the exponent as a product in two different ways. So the way we can write this is b to the 2/3 equals b to the 1/3 times 2. Or another way we could write this is b to the 2/3 equals b 2 times 1/3. Either way, we can think of our power of power property, which we were working with in previous sections. So b to the 1/3 raised to the second power, what we can do is we can then write this with the definition of 1 over b to the n, dealing with the cube root symbol here. So looking at our fraction 1/3, that's the cube root, so cube root of b, and all that is squared. Or the other way we can look at this is we can take the, we have b squared to the 1/3 power. Very similarly, we would write the cube root of b squared. Notice how the b squared is under the radical symbol here. Here it's outside. So that's the difference of how you can write this. Here we have a definition of b to the m over n power. Says in words, a number raised to the power of m over n is equal to the nth root of the number raised to the mth power. So here you have 8 to the 2/3 power equals the cube root of 8 squared. So the cube root of 8 squared is 2 squared, which is going to equal 4. Or here we have 8 to the 2/3 equals the cube root of 8 squared. So what we have here is the cube root of 64, which equals 4. Again, how can you take a cube root on your calculator? Well, you could type 64 with the caret top raised to the 1/3, which will equal, press enter to get 4. That's another way to type a cube root into your calculator. If b is less than 1 and m and n are integers, where m is greater than or equal to 1 and n is greater than or equal to 2, then we have b, m divided by n equals the n root of b to the m power, or n root of b to the m. So I know this is a lot right here, so let's look at some examples dealing with these exponents and the roots and setting it up and solving here. So it says simplify each expression. The first one here we have 16 raised to the 3/4 power. So the way we can rewrite that with a root is it's going to be the quarter root of 16 raised to the 3rd power, which becomes 2/3, which is going to simplify to 8. Looking at b, we have 1 raised to the 3/5 power. The way you could write that based with a root is you have the 5th root of 1 to the 3rd power, which simplifies to 1 to the 3rd. 1 to the 3rd becomes 1. And looking at c, we have 27 to the 4/3 power. So when we write that out, we have the cube root of 27 to the 4th power. That would simplify out to be 4 to the 3rd, because the cube root of 27 is 3, raised to the 4th power, 3 to the 4th, and then you can simplify that out even further. And you get an answer of 81. Working with rational exponents, you want to remember that the radical sign always indicates a non-negative square root. When you simplify variable expressions that contain a radical symbol, such as x squared, the answer cannot be negative. So you can never have a negative answer with working with a radical. But x may be negative. Therefore, you simplify x squared is the absolute value of x to ensure the answer is non-negative. And here's a chart here that when x is positive, the n is even, x to the n is positive, and the way it's set up, it's going to be positive. So please write out this chart to know when x is positive or negative, when n is positive or negative, and what kind of answer you're going to get. Let's look at our last few examples here. Here we have the quarter root of x to the 4th times y to the 12th. So we'll write this out. Now that we have the radical sign, we're going to write it now as an exponent with the fraction. So what it becomes is x to the 4th times y to the 12th raised to the 1/4 power. So I have to think of my exponential rules when solving this. So we have x raised to the 4 times 1/4 power times y raised to the 12 times 1/4 power, which simplifies to x y to the 3rd. Looking at the next one, we have xy raised to the 1/2 power squared, sorry, there's parentheses missing there, over the 5th root of 5 to the 5th power. So how would we write this with the powers here? Well, we distribute, think of our exponent rules. This would be x squared times y to the 1/2 times 2 over, now the way we set this up would be 5 over 5 over 5, which becomes 1, so that's how they got x here. So x to the 5 over 5, so this is the simplified version of that. Then we simplify it out, so we get x squared times 1/2 times 2 is 1, so that's y over x, and that would be my final answer. Actually, the more that we got to take this one step further, I'm sorry. So we have x squared times y over x, so we can subtract the exponents here. So 2 minus 1 just leaves me left with x times y, so my final answer is xy.